Hello everyone. Today we'll be looking into Introduction to Machine Learning. So let's just get started. This is the table of index which we'll be following over the period of videos, and there we'll look into supervised learning, unsupervised learning, and different algorithms in machine learning and how do we actually frame the algorithms in machine learning. So let's just get started. Machine learning is a field of study that gives computers the capability to learn without being explicitly programmed. Machine learning is one of the most exciting technologies that one would have ever come across. As it evident from the name, it gives the computer that makes it more similar to humans, the ability to learn. Machine learning is actively being used today, and it is used in different fields because this is the very hot topic and everyone wants to get the best out of it. So the traditional programming way was we had the data and we had some logic written inside of a program, and then we apply that into our programming, and then we pass it to the data and then we get the output. But with the machine learning, we have the data and we have the output. And the machine learning gives is us a program which has that logic inside it, hidden inside that machine learning program, which learns what output to give for what input. So here we are trying to predict the program, not the output with the program. Machine learning is classified into three major categories. Depending on the nature of learning and the type of data, we have three types of machine learning. First is supervised learning, then we have unsupervised learning, and one different format which is reinforcement learning. Supervised learning, when an algorithm learns from example data and associated targets, response that can be consistent of numeric values of or string labels such as class or tags in order to later predict the correct response when posed with a new example comes under this category of supervised learning. Whereas when an algorithm learns from plain example without any associated response, leaving the algorithm to determine some patterns inside the data, then that type of learning is called unsupervised learning because there is no label to the data. And the third and a different one is the reinforcement learning. Here, we try to make an environment and create an agent which in turns tries to learn about the environment and tries to play within this environment. The reinforcement learning structures the problem as some game. Over the videos, we'll be focusing over supervised learning and unsupervised learning as it is easier to get started from supervised and unsupervised learning. So let's look into what is supervised learning. So as we discussed earlier, supervised learning is when we teach or train the machine using data that is well labeled. Well labeled as in you have the category or the class defined for every data. Data is already tagged with the correct answers. There are no missing gaps. You know what is the final answer to that particular question which you are asking the problem to be solved. After that, machine is provided with a new set of example data, and then we try to predict, okay, on the basis of all the labels which you saw earlier in the data, try to predict this new set of information and try to give us the information, the answer according to this new information. Classification is one of the example of supervised learning. The goal here is to predict the discrete values belonging to a particular class and evaluate based on accuracy. It can be either binary or a multiple class classification. Like we can either say just 0 or 1, or we can actually try to predict different classes. In binary classification, model predicts either 0 or 1, as I said earlier, something like yes or no. And in multi-class, it tries to predict different labels. Let's see some of the examples of classification which we see every day in our life, but never actually see as a classification problem. So whenever you open your Gmail box, your mails are mostly divided into primary, social, promotions, update, and forums. This is the multi-class classification being done right at your doorstep. Whenever you open a Gmail, your mails are divided into these five categories, or you can say five labels. This is the multi-class classification happening. Whoever sends you the mail into your email address, then there a classifier sits. It tells, okay, it reads the email and then judges on the basis of its old information that where it should put this email. The email should go to primary or social or promotion or updates or to forums. These are the new classification. Earlier, we only had spam folder and an inbox folder. This was the old binary classification. The classifier reads all the mail and then tries to predict either it's something informative in this mail or it's just a spam. That was a binary classification, and now we have a multi-class classification. Let's go ahead. Image classification is also one of the example of classification. As you can see in the left side, there are different breeds of dog, and then we are trying to predict which breed of that dog is. This is the machine learning model takes in the image as an input and then tries to label the image as one of the breed of dogs. And as you can see, when we give it some cat, the example of cat, it does not predict any one class. The confidence is low in every class. So this is the image classification as an example. And one of the most um, seen classification problem that we all have seen can be the Face ID. In Apple, whenever you try to open the phone with the Face ID, that that there sits a classifier which classifies either the face which I'm seeing is my owner's face or not. So this is one of the most common classification problem, the classification model sitting on top of our phone, and it's just doing and like classifying every day uh, and helping us to like achieve some good results. The second type of problem which supervised learning does is the regression. It is a supervised learning task where output is having continuous value. The goal here is to predict a value as much as closer to actual output value as our model can, and then evaluation is done by calculating the error values. So it's sort of like we have a lot of discrete data. Suppose we have a lot of data points in our XY plane, but we actually want our continuous function out of these values so that next time whenever we have a new x value, then we can actually predict the value of y on the basis of this function. So regression is this problem, and it is also done in supervised learning. So now let's see different example of regression and the regression problem in everyday life. If you have ever tried to fill some data in Excel, if you give some ascending order of data, like the serial number or some other kind of data, and you try to extend the data, it automatically fills the whole column on the basis of the data which you provided earlier. Like if you just write 1 and 2 and then try to extend that box to 10, it will automatically fill all the boxes from 1 to 10 in ascending order. This is the regression problem. On the basis of just 2 points, it understood the data flow and fills up the boxes automatically. This is the regression happening in Excel. Let's see more examples. So the most common regression example would be the weather forecasting. You might have seen if you try to see the weather forecast, it will try to predict the temperature till tomorrow or till to the next week, and it will try to predict either there will be rain or not and how the weather will be. So this is sort of like a regression problem. It's not just predicting one value, it is telling on what time exactly, what temperature it might be tomorrow on the basis of all the data it has seen earlier. So that is the regression. Weather forecast is a regression problem. Types of regression: linear regression and polynomial regression. Linear regression is a regression which we solve using a linear equations, sort of like we have different data and we are trying to fit a single line which give us the best result. And whereas when the data is not possible to fit via one line, such as if the data is somehow in a circular fashion, then there doesn't exist a single line which can best represent our data. Then we go into our polynomial regression, where we try to fit some polynomial onto our data, and then the problem becomes the polynomial regression. So we talked about classification and regression in supervised learning. Let's just have a recap on how different the classification problem is from the regression problem. So classification is a process of finding or discovering a model or a function which helps in separating the data into multiple categorical classes. As in the picture you can see, we want that line which can distinguish between the two classes. And we want that line to be the best line which can distinguish the two classes or the two planes in our XY plane. Whereas the regression is a process of finding a model or a function for distinguishing the data into continuous real values instead of using classes or discrete values. So in regression, we have the full data, full discrete data, and now we want a function or a line in our XY plane which would best describe the real value when we have a new X pair. When we want a new X and Y pair, when we have the new X value, the best Y value can be possible, can be given through that function or through that line in XY plane. That is the regression, and earlier was classification. So now let's look into what is unsupervised learning. Unsupervised learning is a machine learning technique in which the user do not need to specify the model. Instead, it allows the model to work on its own to discover patterns and information hidden inside the data. It mainly deals with the unlabeled data. And as a matter of fact, most of the data available in the world is unlabeled because we don't have time and resources and human power that much to actually label the sort of data. That's why developing algorithms in unsupervised learning is quite popular because then you can use the most amount of data available in the world. So, sort of the way unsupervised learning algorithms are developed, as in we have some unstructured data, there's no label onto it. We give it to our algorithm, then the algorithm or the model tries to understand and create new patterns that might be useful for some businesses. So let's look into some example of unsupervised learning algorithms which we see every day. So one of the problem which unsupervised learning solves is clustering. Clustering mainly deals with finding a structure or patterns in collection of uncategorical data. Clustering algorithm will process your data and find the natural clusters if they exist in a data. So let's see what are the applications of this clustering algorithm. So one of the most old problem which was solved using clustering is the sizing of the product. For example, the t-shirt size or the shoe size. Because there does not exist a one body type, different people, depending on their height and weight, would require different size of shirt, for example. But the company cannot give you exactly what your size is. Uh, there will they cannot produce every sort of size of the shirt. It just cannot happen in production. They need to have some fixed sizes which they can produce so that their production is very efficient. So they need some sort of size, the range like the small, medium, or large, or maybe the XS, S, medium, large, XL, some category of sizes which in turn will best suit for people, which will be optimal for people, and most of the people can actually get these sizes and they're comfortable within this size range. So this is the product size clustering, which we actually is done inside the industries, and we just see the final product as one label. The another would be the recommender system. This is also a clustering of the data, and there's a multi-billion industry depending on this recommender system only. This is the finding structures in between two people. For example, the user 1 saw A and B on Netflix, and user 2 also saw the A and B, but the user 2 also saw the C. So this clustering helps to supply or to provide this information of C to the user 1, so that the user 1 is most probable that he or she will watch the C. And it applies to, you can take the example of Amazon too. If the user 1 bought A and B, and the user 2 also bought A and B, but the user 2 also bought C somewhere in future or somewhere in time, then user 1 is most likely to buy this C. This is the clustering. This is one type of people which the clustering detected, and then they can focus on advertising this user 2 for C, because the user 1, sorry, is most likely to buy this product then. That's why this is one of the most earned or the most technological dependent thing which like multi-billion technology industry is using.